AI workloads today are resulting in a surge in demand for high-rate S3 file ingestion. AI model training projects, which are based on expensive GPU resources, require massive amounts of data for training. Legacy NAS protocols like SMB or NFS are really not ideal for these kinds of scale. A quick example, SMB has many end-to-end application turns just to move a single file. They also spend a lot of time with SMB locking down files. This is not required of something of S3, which is much simpler. It's based on API calls over HTTPS transactions, typically gets and puts. And S3 is amplified tremendously by a load balancer. Rather than dealing with individual storage nodes like StorageGRID, one can deal with the load balancer's virtual server. S3 clients are also noted to result in very high concurrency, meaning massive amounts of TCP, massive amounts of parallel HTTPS commands, perfect for a big IP. A big IP also, beyond performance, has a very big security story, including things like advanced WAF, rules, API authentication. All of these are in play when HTTPS is the underlying protocol that S3 uses. We'll now log into the Big IP GUI. We'll go immediately to the LTM Local Traffic Manager module and take a look at the pool list. We have a pool list set up for the StorageGRID nodes, 3 of them on port 18082. Everything is green in both the NetApp GUI and the Big IP GUI, as all of our health checks are successful. We'll now look at the Big IP virtual server setup, and we examine it. We can see a descriptive name. We can see a virtual server IP address that consumers of the S3 service will use, and we are going to use 443 for HTTPS. Since we're doing full interception, we'll have a client-side SSL setup and a server-side SSL setup. At this point, the remaining task is just to make sure it's tied to the origin pool. We can see that is the default pool that's been tied to the virtual server. We'll now use an S3 utility, and we'll check some buckets. We see a bucket with a dozen different types of objects. We'll highlight all of the objects and we'll download them to a consumer host, a PC. As you can see, everything came across the S3 protocol. If we just take a quick check of the folder, we can see all of our objects have been transferred. All looks good. To validate that load balancing actually did occur, we'll take a look at the pool and we'll look at statistics. We can see that 2 of the 3 grid nodes from NetApp were used as part of the ingestion. In summary, S3 is experiencing growth due to AI. This stems from AI model training projects where GPUs are requiring tremendous amounts of data. As well, it can be used in RAG implementations where customer files and other data types can be ingested over S3 into vector DBs through an embedding LLM. HTTPS as a transport allows for tremendous performance gains, whereas one singular StorageGRID node might be overtasked. Using a load balancer, you can have a pool of storage nodes, and should there be a health condition with one node, it can be taken out of the pool and not adversely impact the experience of the training exercise. Lastly, Big IP beyond performance scalability has a wealth of security features. These would include things like rules to manipulate HTTP headers, add, modify, delete, as well as something like advanced WAF protections. Thank you.